Good afternoon, dear students and viewers. I welcome all the viewers for this engineering geology lab online class. In today's class, I am going to explain about the identification of economic minerals. Prior to that, as per the syllabus, these are the list of experiments which are to be carried out, which include study of physical properties of common minerals, study of physical properties of economic minerals, and megascopic identification of igneous rocks, sediment rocks, metamorphic rocks, microscopic identification of rocks and minerals, interpretation of geological maps and the study of sections, identification of symbols in the maps of Survey of India topo sheet, and simple structural geology problems. In addition, two more experiments are added which include description and engineering consideration of structural models and electrical resistivity methods. This is the list of experiments which are to be carried out by the civil engineering candidates as per regulations. In today's session, experiment number 2 is explained in detail, that is study of physical properties and identification of economic minerals. Color. It was explained in the previous online class the definition of color. If we recollect the definition, the color of a mineral is the body of color of the mineral. So simply, the body of the color of the mineral is called as color. Usually, the color of the minerals are divided into two categories. One is dark colored minerals and the other one is light colored minerals. When the minerals containing the elements such as aluminium, sodium, potassium, calcium, magnesium, beryllium, if they are present, then the minerals appear as colorless, otherwise light colored minerals. In case if the elements are present, especially iron, copper, manganese, cobalt, titanium, vanadium, copper, if they are present, they become dark. That's why colored minerals are categorized into dark colored minerals and light colored minerals depending upon the presence of elements which are present. Coming to the another property is form. Simply, the form of a mineral is defined as the shape of the mineral. So, the external shape of the mineral certainly reflects the internal arrangement of atoms. That is the meaning of form. So, when a mineral occurs as a well-developed crystal, then we can call it as crystallized. Suppose if the growth of the crystals hampered by surrounding minerals or interference of other minerals, then the resulting form is called as crystalline but not crystallized. And when just traces of crystalline structures are present, then it is called as cryptocrystalline. And if there is no phase and total absence of crystalline structure, then it is called as amorphous or shapeless the form. Coming to another feature, so before that, these are some of the important phases: cube, octahedron, dodecahedron, isosahedron, tetrahedron, where the phases are shown with the green color. Some of the minerals are sometimes characterized with the crystallized phases like this. The next feature is luster. Luster is the nature of shining on the surface of the mineral under reflected light. So a mineral is to be studied under reflected light, how it is shining, that is called luster of the mineral. Then streak. The streak of mineral is color of its powder. So there is a lot of difference between color and streak. In case of streak, we have to obtain the color of the mineral powder by scratching with a nail or with a knife, whatever the procedure is adopted. The obtained color of the powder of the mineral is called as streak. For this purpose, we use streak plate, which is a porcelain plate, unglazed porcelain plate. Another physical property for minerals is fracture. Fracture is the tendency of a mineral to break along curved surfaces without a definite shape. So, the minerals do not have planes of weakness and break irregularly. So, wherever there are no planes of weakness, then it breaks irregularly. Cleavage. Cleavage is the tendency of a mineral to break along smooth planes parallel to zones of weak planes. Wherever there is a weak plane, so parallelly the mineral breaks. Hence, in geology, cleavage is defined as a type of feature that develops as a result of deformation and metamorphism. Hardness. This is another physical property for identification of minerals. So, hardness is defined as the resistance offered by the mineral to abrasion or scratching. I mean, while abrasion or scratching, it should resist. So, for example, if the mineral specimen is muscovite, it's a type of mica. When it is tested on the Mozart scale of hardness, it should not be scratched by gypsum but by calcite. So this is to be remembered. That means calcite hardness is 3, gypsum calcite is 2. That means the muscovite may be in between 2 and 3 hardness. That is, graphite is extremely soft and diamond is extremely hard. This is another feature which is to be remembered. This is called Mozart Scale. A mineralogist, Australian mineralogist, proposed Mozart Scale of hardness in 1882. According to this table, he has selected a few minerals which is finalized as hardness. For example, talc 1, gypsum 2, calcite 3, fluorite 4, apatite 5, feldspar 6, quartz 7, topaz 8, corundum 9 and 10 means a diamond. So with the known of these minerals, we can identify the unknown mineral hardness. Now let us go to economical minerals. If we see the chart, each and every mineral is to be written in such a way: color, iron black; form, granular; luster, metallic, sometimes submetallic; streak, black; fracture, subconchoidal; cleavage is absent here; hardness is 5.5 to 6.5 and specific gravity 5.17 to 5.18 and chemical composition is Fe3O4. And there are varieties in magnetite which are known as taconite and lodestone. And occurrence: small grains of magnetite occur in almost all igneous and metamorphic rocks. Most commonly, magnetite is associated with the metamorphic rocks, also frequently in rocks wherein ferro-magnesium minerals are present, especially diorite, gabbro, peridotite, where we can find magnetite mineral. And uses, it's a valuable ore of iron. If you see the specimen, this is M23, which is called as magnetite and shown clearly in the monitor, and its color is iron black. Coming to the next mineral is hematite. So hematite is black to steel grey in color. Its code is mentioned as M24. So its form is tabular or granular, and its luster is, metallic to submetallic. Streak is cherry red. When we scratch this hematite on a streak plate, we get this cherry red powder, and fracture is uneven, cleavage absent, and hardness is 5.5 to 6.5, specific gravity 5.26, and chemical composition is Fe2O3. And another variety is Martite, which is a variety of hematite, and hematite deposits appear in banded iron formations, and the deposits of hematite are sedimentary in origin, and hematite is a important iron ore. Huge deposits of hematite are found in banded iron formations and important pigment. Coming to the other one is galena. So its code is M25, and it is lead grey in color, and the form is octahedral, but here this is not octahedral. Usually galena occurs in octahedral also. It is shown in the picture octahedral shape, whereas in the laboratory this is not octahedral. Hence we can write massive form here instead of octahedral, and the luster is metallic, but sometimes it shows dull luster, and streak is lead grey, fracture is even, and cleavage is 3 sets. Here when we break this octahedral mineral, it breaks into 3 sets, but not in this case. And hardness is 2.5, specific gravity is 4.95 to 5.10, and its chemical composition is PbS, that is lead sulfide. Usually the pyrite occurs in hydrothermal veins as an accessory mineral in igneous rocks. It also occurs in metamorphic rocks and sediment rocks. And galena is the primary ore of lead, and it is often mined for its silver content. Coming to the another mineral, chromite. Its code is shown as M26. Its color is black, form is granular, luster is submetallic, streak is brown, and fracture is absent, cleavage uneven, hardness 5.5 to 6, specific gravity 4.5 to 4.8, and its chemical composition is Fe2Cr2O3, Cr2O4, and ferrium chromite is another variety in chromite, leopardinaris is another variety in chromite, and this chromite is usually occurs in peridotites, serpentinites, and gabbros. Coming to the uses for chromite. So chromium is allied with iron and nickel. It produces an alloy known as nichrome, which is resistant to high temperatures and used to make heating units, ovens, and other appliances. Coming to the another mineral is called as varieties. So white in color and form it varies. Luster is vitreous, sometimes pearly. Streak is white. Fracture is irregular, and cleavage is good. Hardness 2.5 to 3.5, specific gravity 4.5. Its chemical composition is barium sulfate, that is BaSO4, and it occurs as concretions and void filling crystals in sediment rocks. Also it available along with limestone. Varieties also found in sandstone, and it is used as a drilling mud and a high density filler for paper manufacturing unit, rubber, plastics. Coming to the next mineral is coal. So this is the coal. In fact, coal is a rock, but its economical importance, by considering its economical importance, the geologists have considered this as an economic mineral. In fact, it is a rock. Mineral means it should have a definite chemical composition, but its chemical composition varies from one variety to another variety, because coal has so many varieties: peat, lignite, bituminous coal, anthracite coal. So each coal percentage, carbon content varies. So its color is black, form is massive and dull luster, black streak, conchoidal fracture, cleavage is offset, hardness is 2.75 to 3, and its specific gravity of course varies from one variety to another variety, and coal is formed when plant debris is accumulated for years together, so that it converts into peat and then it converts into coal because of the heat and pressure of deep burial over millions of years. So coal is used in producing electricity, especially in case of thermal power plants, steel production plants, cement manufacturing units, and refined coal tar is used in the manufacture of chemicals such as creosote oil, naphthalene, phenol and benzene. Thousands of different products have coal or coal byproducts as components. Soap industry, aspirins, solvents, dyes, plastics and fiber industries also use coal as rayon and nylon. The next mineral is pyroxide. Pyroxide is marked as M29. This is the pyroxide. It's iron grey in color. Form is massive. Luster is metallic. How it is shining, we can see how it is shining. Bluish black is the streak. Uneven fracture. Indistinct cleavage with 6 to 6.5 hardness. Specific gravity is 4.4 to 5, and its chemical composition is manganese oxide, that is MnO2. So polonite, silomalin, rhodochrosite are the varieties in pyroxide, and pyroxide usually occurs with magnetite, hollandite, hasmonite, braunite, chalcophanite, goethite and hematite under oxidizing conditions in hydrothermal deposits. Coming to the uses of pyroxide, it is used in the manufacture of steel and manganese, bronze in dry cells and as a decolorizing agent in glass. The next economic mineral is graphite. So graphite is mentioned as M30. It has iron grey in color, crystalline form, metallic luster. It shines beautifully and streak is black, conchoidal fracture, cleavage is perfect and hardness is recorded as 1 to 2, whereas specific gravity is 1.9 to 2.3 and its chemical composition is purely carbon. And graphite occurs in metamorphic rocks as a result of the reduction of sedimentary carbon compounds during metamorphism. It also occurs in igneous rocks and in meteorites. Whereas if we discuss about the uses of graphite, which can be used in pencils and lubricants, it is a good conductor of heat and electricity. Its high conductivity makes it useful in electronic products such as electrodes, batteries and solar panels. So coming to the another economic mineral is bauxite. It is usually reddish brown in color, very rarely occurs in white in color. Form is pisolitic, that means we can see the circles or semicircles. This is called pisolitic. Luster is earthy, that means dull luster. Streak is brown or sometimes white. Fracture is uneven. Cleavage is offset. It breaks in different directions. And hardness varies from 6.5 to 7, that is for diaspore, that is a variety in bauxite, and bohemite, where the hardness is 2.5 to 3, and gibbsite is also another variety, specific gravity 2 to 2.5, and bauxite does not have a specific composition. It is a mixture of hydrous aluminum oxides, aluminum hydroxides, clay minerals, and insoluble materials such as quartz, hematite, magnetite, siderite and goethite. The aluminum minerals in bauxite include gibbsite, bohemite, diapsone, etc. And bauxite ore is the main source of aluminum and contains aluminum minerals of whatever we explained. Bauxite is a rock formed from the weathering of either silicate rocks, granite or basalt or carbonate rocks. However, we can consider this one also as economic mineral because the maximum aluminum content is getting from this rock. However, bauxite is a rock, but we are treating it as economic mineral. So, bauxite is aluminum rich ore that is used for aluminum production and for production of refractory materials such as chemicals. Metallic aluminum is used in transportation, packaging such as beverage cans, building construction, electrical applications and other products. Especially the transmission lines of power, the cables are used with the help of aluminum element. These are some of the parameters: hardness, density, cleavage for some of the economic minerals. So pyrite, hematite, magnetite, chromite, galena, pyroxide, graphite, magnesite, bauxite are shown with the hardness, density and cleavages. Thank you. Thank you.